This is the screencast for Lesson 24 in Stephen's C# 24-hour trainer. This lesson talks about constructors and destructors. And in this example, we're going to add constructors and destructors to the person, employee, and manager classes. So for starters, in the person class, let me add a constructor that takes a bunch of parameters and initializes the object's properties. I call this an initializing constructor because that's its main purpose in life. So I'm going to say public person, and then now we give it a parameter list. So this is going to be one parameter for each of the properties we want to initialize. So I'm going to say first name, string, last name, string, street, city, state, and zip. And all it does is initialize these values. So first name equals first name, and so on. Incidentally, if you happen to type one of these wrong and get the case wrong, so for example I say city equals city, both lowercase, watch what happens. Actually, I messed up several of these. We get the green squiggly underline, and if I hover over it, it says, warning, assignment made to same variable. Did you mean to assign something else? So that's kind of clever of it. It knows that I'm assigning a value to itself, and that's probably a mistake. So let me correct these other mistakes. Okay, so now we can create a person object using this constructor. So let me go over here to the forms code, and in this section I'm going to create some people. So I'm going to say console.writeLine. I want to sort of keep track of what's going on in this program in the console window so we can see when things are created and destroyed. So this is going to be creating Alice. So I'm going to say person Alice equals new person. And if I try to do it like this, notice what happens. It says person does not contain a constructor that takes 0 arguments. So by default, if you create a class and you don't give it any customized constructors, you do get a default constructor that has no parameters. So you could say this. You could say person Alice equals new person. But by creating any constructor at all, in this case one that takes a bunch of parameters, that gets rid of the default constructor. So it's no longer there. So I can't use this anymore. Now I'm going to have to pass parameters in. So we'll say Alice Anderson, what else? Street 12 somewhere. City, we'll put this in Colorado, and there's a zip code. Okay, so now it's happy. It likes this constructor because I've given it the right number of parameters. If you want to use a parameterless constructor, then you need to create one yourself if you've also created other constructors. Let me try to make Bob here. Let me do a console.writeLine. Creating Bob. So here I'm going to use the object initialization syntax. So I'm going to say first name equals Bob, last name equals Benedict, street equals somewhere else, city equals Crash, state equals, we'll put this in Arizona, and finally a zip code. All right, now you notice when I press the semicolon that C# reformatted everything. This syntax is correct, but it's still complaining because we don't have this empty parameter, this parameterless constructor. So let's go back here and create one in the person class. That's pretty easy. We just say public person, no parameters, and we don't need a body either. If we were going to initialize something in the class, we could put it in here, but we don't need to, so we're not going to in this case. So now this code is happy. All right, let me build some constructors for the employee class. Right now, the employee class has its default constructor because we haven't given it any explicit constructors. If I go back over here to the main program, I left the code in that creates employees. So if we scroll down here, we can see this one is happy because it's using the default parameterless constructor and then object initialization syntax. This one is not happy because I'm invoking this constructor that takes a whole bunch of parameters. So let's go and create that one. So I'll say public employee, and here's where I need all my parameters. Well, most of them are the same as the person class, so I'm going to copy and paste these. So I'll copy those, paste them in here. We also have two new parameters to initialize these two properties that are added by the employee class. So I'll say string, oh, sorry, this is an int employee ID, and now string mail stop. Now you could go ahead and initialize all of these here. You could say first name equals first name. But that would require a lot of duplicated code because that's the same thing that this constructor over here does. It already does all of that. So instead of duplicating that code, what I'm going to do is invoke that constructor from this constructor. So the way we do that is after this parameter list, we say colon base, and then we give it the parameters that we want to pass to that constructor. You'll notice that IntelliSense even shows us the constructors available. There's one that takes no parameters, and there's one that takes all of these parameters. That's the one we're going to use. So we'll pass in first name, last name, street, city, state, and zip. So that's going to pass those parameters to the person class's constructor that takes those parameters. It will initialize those fields, and all we need to do in this constructor is initialize the remaining fields. So employee ID equals employee ID, and mail stop equals mail stop. So that's all we need to do for this one. Now if we go back to the main form again, we'll see this constructor should be working. What is its complaint now? Oh, it looks like I changed the order from the way I originally had this thing. Looks like I put the employee ID and the mail stop first in the parameter list, and now I've got them at the end. So we'll just move those. So now this constructor is happy, but this one is upset because we took away the default constructor by building a constructor on our own. So we need to go back and create that. So we'll just say public employee, no parameters, and no method body. Okay. So that's all good. Now I also want to be able to track construction and destruction as we go through here. So I'm going to add a little bit of extra code to all of these constructors. We'll just throw in some console.writeLine statements. So console.writeLine. And here I'm just going to say person with empty parentheses. So I know here we've called the constructor that contains no parentheses, or that contains no parameters. And then down here I'm going to do one. I'm just going to say parameters inside. So we know we've invoked that constructor. And then let's do the same here for the employee class. And this is the one with parameters. And then finally, I want to create some destructors for these things so we can tell when they're being destroyed. So to create a destructor, we're just going to say public, sorry, we don't even need the public, just twiddle employee. And then in here, I'm going to do a console.writeLine statement. We're just going to say twiddle employee, so we know it's being destroyed. So here we have twiddle person, console.writeLine, twiddle person. Okay, so we've given these classes two different constructors, one that's an initializing constructor and one that's a parameterless constructor. also sometimes called an empty constructor. And we've put a bunch of console.write lines in here so we can see what's going on. We've also created destructors. And I won't make you sit through while I do the manager class. I kept that code the way I already had it. So here we've got a parameterless constructor, and here's a constructor with parameters. And it looks like, again, because I changed the order of these parameters, let me change them here as well. So that hooks up. Also notice, here's something I forgot to do for the others. For the parameterless constructors, this invokes the base class's parameterless constructor. That's generally good practice. So let me add that here. We'll add that to the employee class. The reason that's good is in the person class, perhaps the parameterless constructor does something important. Maybe it initializes a data structure, builds a list or an array or something like that. If that's the case, we want to make sure that it gets called from the employee class's parameterless constructor as well. So in general, if you have a derived class and you're implementing a constructor for it, you probably want to at least think hard about whether you want to call the base class constructors. So let's run the program and see what happens here. Oh, let me show you the code for the program. So here's the forum's load event handler. It creates some persons. It creates Alice and Bob and initializes them. Then it creates an employee named Edna and an employee named Edward. Then down here it creates a manager named Mindy and a manager named Mike. And all this code does is it just creates them in two different ways. It uses the object initialization syntax, and then it uses our initializing constructors. So that's all this program does. It creates a bunch of objects. So let's go to the output window and see if we can find our output. Now I've noticed this with Visual Studio, this version. Sometimes it doesn't display anything in the output window if the window isn't visible when you start running the program. So let me stop it and start it up again. And hopefully this time, there it is. Let me pin it so it doesn't go away this time. So now we can see all of our constructor messages. So these messages that say creating are printed by the main program, and then these messages are the constructors messages. So we created Alice. There's Alice's constructor. We're creating Bob. There's Bob's constructor. It used the empty constructor. We're creating Edna. Now Edna is an employee, so the first thing the constructor does is it invokes the base class's method. So there's the person constructor. Then the employee's empty constructor. When we create Edward, also an employee, so it invokes the base class's parameterized constructor and then the employee class's version. Mindy is a manager, so it does the same sorts of things. Calls the manager constructor calls employee, which calls person. So person happens first, then employee, then manager. And then the same for Mike. Person, then employee, then manager. Okay, and at this point, the program is running, and you notice there are no destructors. They haven't been called yet. Although the form here created these variables inside its load event handler, see, they're defined right inside here. So they're out of scope now. The form load event handler is done running. So these variables, in some sense, no longer exist. But the objects they refer to do still exist in memory. The program can't access them, so as far as we're concerned, they may as well be gone. But they're not. They're still in there, taking up space. Now if I close the program, let me bring the output window back, you can see all of the destructors got called. So in this case, none of these objects were actually destroyed until the form quit. Their memory was lost to the program, but it was still being taken up. And the garbage collector never ran for this program until finally the program exited. Now if the program crashes, the destructors may not execute. So that's an important thing to know. It's also interesting to notice that these destructors call each other. So when you destroy a manager, it also calls the employee destructor, which also calls the person destructor. So we've got a lot of persons here being destroyed, and for example, only 2 managers. Finally, it's useful to note that in this case, it looks like it may have destroyed the objects in the reverse order in which they were created, but you shouldn't count on that. The garbage collector is free to do whatever it feels like, and we really shouldn't rely on any particular features of the order in which it does things or when it does things. All we can really be sure of is that at some point these objects may be destroyed.